Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic continuity and differentiability. We will see continuity of a function at this video. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answers. Well, let us see what do you mean by continuity of a function at a point. Let us start. Kindly observe the graph of the following function. F of x is equal to sin x. This is the graph of it. You observe the graph of the following function. X plus 2 for x less than or equal to 1. X minus 2 for x greater than 1. You are able to observe something in the graph of both the functions which we have discussed. Good. Let us see the animation of that. Suppose you are seeing the graph of sin x. Now it comes down and it goes up at origin. It goes up at pi by 2. It turns. Again at pi it comes down and it stops. What do you observe over here? I have observed here that we can draw the graph without lifting the pen. Without lifting the pen, I am able to draw the graph. Let us now see the graph of the other function which we discussed. It starts now. It is going up to 2. Okay, at 3 again. At 1 comma 3 there, then again from minus 1 comma when it starts, again it goes. This is a graph of the function which we discussed, the second one, that is x plus 2 for x less than and then x minus 2 for x greater than 2. But now we are seeing over here we cannot draw this graph without lifting the pen. Therefore we saw 2 graphs now. One graph we can draw the graph without lifting the pen. Another graph we cannot draw without lifting the pen. First one, f of x is equal to sin x, you can draw it without lifting the pen, but the second one you cannot draw without lifting the pen. Therefore, suppose f is a real function and the subset of a real number, and let a be the point in the domain. Let if f is continuous, if limit x goes to f of x is equal to f of a. What we have seen in the previous 2 functions, one function is called a continuous function, other one is not continuous. We are now defining the continuity at a point. Limit x goes to a, f of x should be equal to f of a. Left hand side is we are finding the limit value. On the right hand side we are finding the functional value at that x is equal to a. Now you are seeing over here that this function is continuous at all points and this function is not continuous at x is equal to 1. There is a break at x is equal to 1, there is a break. Therefore this function is not continuous at x is equal to 1. A function is continuous at x is equal to a if the function is defined at x is equal to a and if the value of the function at x is equal to a is equal to the limit of the function at x is equal to a. If f is not continuous, we say that f is discontinuous at a and a is called the point of discontinuity. In the previous example, we saw that x is equal to 1 is the point of discontinuity. Therefore, x is equal to 1 is the point of discontinuity. Fine. Now, to check the continuity of a function at a point, what we have to do? Let us check whether f of a is defined. What is the meaning of f of a defined? All of you know that if you are talking about real valued function, this f of a should be a real number. So that 1 by 0 should not come and negative number inside the square root is not allowed. Therefore, f of a should be defined. It should have a definite value. Then limit exists. All of you know what is the meaning of limit exists. Right hand side limit should be equal to the left hand side limit. Limit x goes to a plus f of x is same as limit x goes to a minus f of x. And the value which you have found in the first one, that is the f of a functional value, should be equal to the value which you have obtained from the second one, That is the limit value should be equal. Limit x goes to f of x is equal to f of e. Suppose we have just seen that what do you mean by continuity at a point. Now this is a continuity at an interval. If you are going on extending it, suppose f is a function defined on a closed interval ab, then f is to be continuous if it needs to be continuous at every point in ab, including the endpoints a and b. Suppose if you are telling that a function is continuous from 0 to 1, it should be continuous at all the points lying between 0 and 1, including 0 and 1. Good. Suppose if you are taking a function from R to R, a real function is said to be continuous if it is continuous at every point on the domain of f. All of you know that a function will be defined from a set to another set. The left hand side set is called the domain. It should be continuous at all the points of the domain, then only it will be called a continuous function. Now we are looking after here. Here f of x is continuous at every point. We are seeing it here. F of x is continuous at every point. We are just seeing here f of x is equal to 1 by x is continuous at every point. And suppose if you take f of x is equal to greatest integer function, it is discontinuous at all the integer values. Let us see how it happens. And suppose whenever you are taking this function now, you are seeing that how it happens now. It is going, and at every one it is having some break. That is 1, there is a break. At 2 it breaks. At 3 it breaks. At -4, -3, -2, -1, 0, 1, 2, 3. Therefore, it is discontinuous at all integer values. To check the continuity of a function defined in a domain, we have to check the continuity at all the points in the domain. To check the continuity of a function, f of x defined as f of x is equal to g of x for x less than a, h of x for x greater than or equal to a. We have to check the continuity for less than a, greater than a, and equal to a. The meaning is we are checking the continuity at all the points. Let us go to question number 1. You have been asked to check the continuity of this function for x not equal to 0. It is x square into sin 1 by x, 0 when x is equal to 0 at the point x is equal to 0. Be careful in the exam. Sometimes they will ask you to check the continuity at a point. Otherwise, they will ask you to check the continuity in the whole domain. Sometimes they will ask you to check the point of discontinuity. They want you to simply show them the point of discontinuity. This problem we have to check only at 0. Therefore, f of x is continuous. If limit x goes to 0, f of x is same as f of 0. I am just putting the definition before you. Let us first find what is f of 0. At x is equal to 0, f of 0 is 0 given. Therefore, your limit value should be 0 now, otherwise it is not continuous. Let us go to limit value now. Limit x goes to 0, f of x is limit x goes to 0, x square into sin y by x, which is nothing but there are two terms are there by making use of property of limits. Limit x goes to 0, x square multiplied by limit x goes to 0, sin of 1 by x. And first number is 0, second number is limit x goes to 0, sin of 1 by x. 0 into any number is 0. Therefore, I am getting limit x goes to 0, f of x is same as f of 0 is equal to 0. Therefore, the function is continuous at x is equal to 0. Now move on to question number 2. We have to check the continuity of this x power 4 plus 2x cube plus x square upon tan inverse x if x not equal to 0. 0 for x is equal to 0 at x is equal to 0. Same definition. It is continuous if it limit x goes to 0, f of x is same as f of 0. All of you should be strong in that limit calculations, because that is a major part in checking the continuity of a function. At x is equal to 0, what is f of 0 given? It is 0, because if x is equal to 0, the answer is 0. Well, now I am going for finding the limit. Limit x goes to 0 of x power 4 plus 2x cube plus x square by tan inverse x. For that, all of you know that for tan inverse x, to convert it into a standard limit, we need x. Therefore, we are writing it as x square by taking it out from the numerator. X square into x square plus 2x plus 1 upon tan inverse x. Once again, I am writing it as x into x square plus 2x plus 1 multiplied by x upon tan inverse x. As I already told you, I am always interested to get the standard limit. For tan inverse x, I need x. Let us split the limit into two. Limit of the first one into limit of the second one. Therefore, by putting x is equal to tan t in the second one, I am putting t is equal to tan inverse x, and when x goes to 0, t goes to 0. This already was seen it in class 11, how to evaluate a limit using substitution. For first one is limit x goes to 0, x into x square plus 2x plus 1 into limit t goes to 0, tan t by t, because x is tan t and tan inverse x is t. Now the first one is 0 into 0, 0 plus 0 plus 1. Second one is a standard limit, the answer is 1. Therefore, the answer is 0. 0 into 1. Therefore, limit x goes to 0, f of x and f of 0 are same. You are getting the final answer as 0. Therefore, the function is continuous at x is equal to 0. Here, kindly check out how this limit value is evaluated using properties of limits which you studied in lower class. Well, as I told you earlier, some types of problem will be like this. Find all the points of discontinuity of the function mod x by x for x not equal to 0, 0 for x is equal to 0. Mod x is equal to 0, mod x by x, what is the meaning of it? It will be x for x greater than 0 and minus x for x less than 0. All of you know the speciality of mod x. Therefore, when I want to convert this problem like this, it will be mod x by x which is equal to minus 1 for x less than 0 and 0 for x is equal to 0 and mod x by x for x by x, that is 1 for x greater than 0. This function can be converted like this. F of x is equal to minus 1 for x less than 0, 0 for x is equal to 0 and 1 for x greater than 0. I have just converted it making use of the property of mod x. Okay, now let us try to check this one at any real number. I am taking real number. We will check a less than 0, equal to 0 and a greater than 0. For a less than 0, f of x is minus 1. Therefore, f of a is minus 1. Limit x goes to a of f of x is limit x goes to a of minus 1. Therefore, minus 1. For no issue in that, limit x goes to a, f of x is equal to minus 1 is equal to f of a. Therefore, it is continuous for x less than 0. Now, some of you may directly do it also. This f of x is minus 1, which is nothing but a normal polynomial function. Therefore, it is automatically continuous. You can directly write also, but anyway, I have proved left hand the limit all value is equal to functional value. Let us go to case 2. A is equal to 0. This is very, very important. Let us find f of x. It is 0. F of 0 is 0. And at x is equal to 0, we have to check the right hand side limit and left hand side limit. This is the right hand side limit. X goes to 0 plus means greater than 0, therefore 1. Limit x goes to 0 minus means less than 0, therefore minus 1. Please check out how the f of x is selected. X goes to 0 plus means x is greater than 0, therefore 1 is selected for f of x. X goes to 0 minus means it is less than 0, therefore minus 1 is selected. Now you are seeing that limit does not exist. No need to check whether it is equal to the functional value. Therefore, limit does not exist. Therefore, it is not continuous at x is equal to 0. Let us go to the third case. In the third case, very simple. F of x is 1 over here. F of a is 1. Well, limit value is equal to f of limit x goes to a 1, that is 1. Therefore, limit value and the functional value are one and the same. Therefore, it is continuous for x greater than 0. Therefore, we have a final conclusion now. It is continuous for x less than 0, not continuous at x is equal to 0, and continuous for x greater than 0. Now, from this, what is the point of discontinuity? X is equal to 0 is the only point of discontinuity. Now, if you want to see the graph of this function, and you can see, this function modulus x by x, it goes up to that 0, again it takes a break, again it goes from 1. But this function is not continuous at x is equal to 0. Below 0 it is a straight line, greater than 0 also it is a straight line, therefore it is continuous over there. Good. Let us go for another types of problem where you will be given continuity and you will be asked to evaluate a constant. For that, you have to use the idea that limit value is equal to functional value. As f of x is continuous, the limit value should be equal to the functional value. Let us equate it now. Limit x goes to 0 of the function should be equal to f of 0, that is k. I am taking 1 by 3 outside in the first limit. It is limit x goes to 0 sin phi x by phi x. All of you know, if it is sin phi x, it should have phi x in the denominator, so that you can get a standard limit. For I am multiplying and dividing by 5, and limit x goes to 0 cos x is the second one. For the first one is 1 by 3 into 5 into 1. All of you know 5 comes out, and limit x goes to 0 sin phi x by phi x is 1. Therefore, the value of k is 5 by 3 plus 1, therefore 8 by 3. Here all of you are seeing here, this problem is very simple. If you know the method of evaluating limit, you can get the answer directly. We'll go to the next question where you have been given a function, it is a continuous, and you have to evaluate the value of a and b. Therefore, the function is continuous given, therefore it is continuous at x is equal to 2 also. Continuous means it is continuous everywhere. Therefore, limit x goes to 2 plus of f of x should be equal to limit x goes to 2 minus of f of x should be equal to f of 2. The meaning is limit x goes to 2 of f of x is equal to f of 2. Limit exists means left limit is equal to right limit. Therefore, limit x goes to 2 plus means greater than 2. Therefore, I am taking the function 2ax minus b. X goes to 2 minus means x is less than 2. Therefore, I am taking the function ax square plus b. F of 2 is automatically 2 given in the question. I am now applying the limits now. It will become 4a minus b equal to 4a plus b is equal to 2. You can equate 4a minus b is equal to 2 and 4a plus b is equal to 2. Value from the right limit is equal to 2. The value from the left limit is equal to 2. Let us continue with these equations. These are the two equations. How to cancel it? You have to do the elimination process. 2 minus 1. You will get minus 2b is equal to 0. Therefore, b is equal to 0. When you put b is equal to 0 in any of the equation as per your choice, you will get 4a is equal to 2. Therefore, a is equal to 1 by 2. For a is equal to 1 by 2 and b is equal to 1. Thank you. Success is dependent on efforts. All the best.